Hello everyone, thank you for being here today. I'm Aman and today I will be presenting to you all our work on hate speech detection in limited data contexts using synthetic data generation, which was done with my amazing colleagues Daniel, Johnny and Dr. Best. Please note that this presentation contains a few offensive and hateful terms and I've tried to mask them at most places, but they're still present at some places for explanation, and I hence advise the audience to take care by listening to the presentation. So let's head in. I'll begin this talk by describing the context of our research. Our research is set in two countries in Global South, India and Vietnam, where we tackle hate speech in Hindi and Vietnamese. India, which is the world's largest democracy and the most populated country in the world, with the maximum number of Facebook users, in recent times, India has been grappling with the problem of hate speech on its social media platforms, with the social media platform like Facebook failing to have an effective content moderation system in place. Hate speech has also been responsible for riots in the country in recent times. Hence, tackling the problem of hate speech in this context is an important problem which we look at in our work. Our next context of interest is Vietnam, which has been a socialist state since 1976 under the political rule of Communist Party of Vietnam. It is the 15th most populated country and has the 7th highest number of Facebook users in the world. In recent years, the country's ruling party has cracked down on free speech, with the country ranking 178 from 180 nations in the World Press Freedom Index, only above China and North Korea. Moreover, in the claim to curbing misinformation and hate speech, the government has been introducing social media policies which are further stifling free speech and freedom of expression in the country. Hence, it again becomes important for us to understand which social media content is actually hate speech or if it is an attempt to limit free speech. The context hence also forms a focus of our interest. In 2020, in the months leading up to the Myanmar elections, we carried out a similar study to tackle hate speech in Myanmar, where we took the help of context experts to curate a hate speech dataset to train the machine learning models. However, when we shifted our context from Myanmar to India and Vietnam, we found that even though the methodology itself was transferable, but it was challenging to replicate the efforts. Because data annotation is time-consuming, costly and harmful to the mental health of the moderators. We hence asked if there could be a more transferable way to tackle hate speech whenever we shift our context of interest. This motivation led to the question we asked through our work. Can we leverage a high-resource language like English to synthesize hate speech in our context of interest? I will now define some terms which I used during the presentation. The first is high-resource language. These are languages with ample availability of digital data broadly and hate speech data specifically. It is easier to train machine learning models in these languages, for example, English and Chinese. The second is low-resource language. These are languages with a sparse quantity of digital and hate speech data. It is hard to train machine learning models in these languages, for example, Burmese and Amharic. Next, we define the context of our interest as the limited data context. These are languages with relatively higher digital data but less hate speech data. It is hence harder to train hate speech detection models on these languages. There also exists class imbalance, that is, there are much more non-hateful posts than hateful posts. Some examples include Hindi and Vietnamese. Lastly, synthetic data refers to the automatically generated training data for machine learning models, which does not require human annotation for the specific task. Our work looks at how we can generate good quality synthetic data in the limited data context of our interest so that we can tackle hate speech in a more scalable way across demographics. Our work builds on three subfields of work. The first being that of hate speech detection in low-resource languages, where researchers have curated hate speech datasets in low-resource languages by leveraging the knowledge of context experts. The second field looks at transferring context across languages, and researchers have exploited similarities in the low and high-resource languages. Moreover, researchers have highlighted the importance of targeted demographics like gender and race in hate speech datasets. Finally, the field of data augmentation using synthetic data generation has been growing with the emergence of large language models, but to the best of our knowledge, we are among the first works in non-English languages where the large language models still have limited performance. Now I'll be describing the various methods in which we generated the hate speech dataset in our context of interest. The two key characteristics of any synthetic dataset are naturalness and diversity to emulate characteristics of an original training data. To these ends, we leverage three techniques, namely machine translation, contextual entity substitution, and Bloom language model, and I'll be explaining all three in the next few slides. As the name suggests, the machine translation method simply translates the hate speech posts from the curated dataset in English to our language of interest, which are Hindi and Vietnamese. This method, however, falls short specifically for hate speech because of the contextual nature of this task. In the example shown in the bubble, we observe that the automatic translation, the English named entities like Kelly and extremely derogatory term for Muslims in purple simply get transliterated, that is the same word but in Hindi script, while the abusive term in yellow is lost in translation. As you can imagine, this transliteration has gaps since the target individuals and groups are different in India and Vietnam as compared to the American context. Even the derogatory terms are different in India and Vietnam, and simple transliteration would not be natural to the limited data context. In an attempt to bridge this gap, we developed the contextual entity substitution methodology to help increase the naturalness in the quality of the generated synthetic data. The main idea of this method is to identify the target entities subjected to hate or hate terms in a high resource context and substitute them with entities and hate terms for the target limited data context. The example shown at the bottom exhibits how the individual names in black, abusive terms in yellow, and target groups in purple targeted towards hate have been shifted from the American context to the Indian context. In this presentation, I will just cover some key steps to carry out the contextual entity substitution methodology. The details are present in our paper. This method involves building an entity table in the high resource context. This entity table is an instantiation of the practice of creating lexicon lists as done in other works in the literature. To create the entity table, we categorize the lexicons into target groups, target individuals, hate terms, target countries, and political groups. We created a similar entity table for the target context. To create this entity table, we asked two native speakers of Hindi and Vietnamese to review a sample of hate speech posts and identify the hate target entities. These entity tables are used for entity substitution and replacement to get the hate speech post in the limited data context. Finally, a third method involves leveraging the multilingual Bloom language model with 3 billion parameters to generate the synthetic hate speech posts. As shown in the example in the box, we pass 5 hate speech posts from the target context and prompt the language model to generate the 6th hate speech post. Using the 3 methods described previously, we generate the synthetic training datasets in both Hindi and Vietnamese. Only the hateful posts are synthetically generated, while the 450 non-hateful posts are taken from the limited data context due to the class imbalance property. Instead of using all synthetic hateful posts, we use 100 original hateful posts from the limited data context, a value empirically derived through our experiments. Next, we increase the amount of hateful posts by synthetically generating up to 350 hateful posts and testing the performance at various points. Next, we test our models on a held-out test set from the limited data context, which includes around 400 testing data points in Hindi and around 5,000 testing data points in Vietnamese. We also test on an out-of-domain test set which was collected from a different manner as compared to the training data we use. Finally, we evaluate and compare all the models using macro F1 score, a metric which is usually used in this field of research. Now, I will describe a part of the results from our work. For the complete set of results, please refer to our paper. The baseline model is the model trained using 450 non-hateful and 100 hateful posts, all from the original language in the limited data context. Next, we augment the 100 original hateful posts with the synthetic hateful posts and keep increasing the augmentation count. In this particular set in red, we augmented the data set with 50 synthetic hateful posts. For Hindi, we found improvement from the baseline through all the three methods, while the maximum gains were through the contextual entity substitution method. For Vietnamese, we find that none of the methods were able to outperform the baseline, which we speculate could be due to the triple or 4 times the amount of pre-training data of Vietnamese as compared to Hindi, both for multilingual BERT and Bloom language model, or due to the limited size of the Vietnamese entity table. Next, we augment 250 hateful posts. We find similar trend for Hindi, but for Vietnamese, we find the Bloom language model to shine the most. Finally, when we augment 350 hateful posts to make the total hateful post count 450, which is equivalent to the non-hateful post count, we find the best performance both for Hindi and Vietnamese. While the contextual entity substitution method continues to shine for Hindi, the Bloom language model provides better results for Vietnamese. Through our work, we find that the contextual entity substitution method helps bridge the gap in machine translation, but the gains in Vietnamese are limited due to the relatively smaller entity table, which illustrates the importance of involving context experts in building the entity table and revising them based on the model performance and shortcomings. This work provides a new use case for the multilingual large language models and offers insights into techniques for prompt engineering to improve the quality of dataset by making it more natural and diverse. Through our work, we find that there is no one best method to create the synthetic data. When entity table is comprehensive, CES wins. When language is well represented, Bloom LM wins. And these two mostly shine brighter than the machine translation methodology. To conclude, in this work, we investigate 3 approaches to generate synthetic hate speech data and augment the existing hate speech datasets in limited data contexts. We present a novel methodology to transfer hateful sentiment across languages while retaining contextual relevance. Finally, to the best of our knowledge, our work is among the first few works to propose synthetic data generation methodology for detection of hate speech in Global South. One limitation of our work is that our methods have been tested in Hindi and Vietnamese, which have relatively high automatic machine translation quality, and the performance on low-resource languages is unclear. Finally, the broad goal through this work is to showcase the possibility of use of synthetic data for social development, a space where researchers often face problems in curating training data. Finally, I would like to thank each and every one of you for your time and our wonderful partners for funding this work and providing the required compute. Thank you.